Yeah.
Lithium-ion batteries power most of our devices today, but they have big problems that scientists need to solve. These batteries use lithium, which becomes harder to find around the world. The more people want electric cars, energy storage, we're running out of this important material. The biggest issue is how these batteries work. Lithium-ion batteries can only use ions that carry one positive charge. This limits how much energy they can store. Think of it like a bucket that can only be filled halfway. There's wasted space that could hold more storage. Scientists have discovered that multivalent ion batteries could solve this problem. These new batteries use ions that carry 2 or 3 positive charges instead of one. This means they can store much more energy in the same space. It's like upgrading from a small bucket to a large container. The battery material alternatives focus on finding abundant materials like magnesium and zinc. These materials are much easier to find than lithium, and they could help create sustainable next generation batteries that don't rely on rare materials. What's going on here, John?
Yeah. So the NGIT research team, what they did was they employed a sophisticated kind of dual AI approach, which combined a crystal diffusion variational autoencoder or cDVAE with a fine-tuned LLM to overcome the fundamental challenge of exploring vast materials in the design space. So I don't know why they needed this. So I didn't really do a deep dive, but this is really interesting. So the cDVAE component, it was trained on a bunch of data sets of known crystal structures, which enabled it to generate completely novel materials with diverse structural possibilities by learning the underlying patterns of atomic arrangements and bonding preferences in stable materials. So the way the system works is through a diffusion process that moves atomic coordinates toward lower energy states while simultaneously updating atom types to satisfy bonding preferences between neighboring atoms. So that's the cDVAE. Now, the LLM component was specifically tuned to identify materials closest to thermodynamic stability, which is obviously a critical factor in determining whether theoretical materials can actually be synthesized in laboratory conditions. So the dual approach that they did allowed the AI to simultaneously optimize for both structural innovation and practical feasibility, which dramatically accelerated the traditionally slow trial and error process of material discovery. And what they discovered, like what you said, was multivalent ion batteries, which represent a fundamental departure from this lithium-ion technology. So this is cool. I like how their approach to this, and this is the stuff that I like. And I know we've covered things where they've had LLMs do drug discovery and different things like this. I love it that they're using it for battery technology. Although we have covered a bunch of different battery technology, right?
Yes, it seems a regular thing because let's face it, it's a limiting factor in our world today, our existing batteries, and we've been promised new and improved batteries for years and years and years. And it seemed like they're right around the corner, but it felt like it's been right around the corner, like for how long now?
Forever. Yeah.
Yeah. And like we've had the iPhone for how long, and we get like a couple hours extra battery life every,
Yeah. And that's only because of increased efficiency in the chips for the most part, not because they're implementing they're a little bit larger battery, but yeah.
Yeah. I mean, it's larger, but it's not significant change in battery technology. They just
No.
more battery, less power from other stuff. We get more efficient at those things. So when better battery technology actually comes along, it's going to be exciting. Um, this is great. I love when AI gets involved and finds new discoveries. I was not expecting this to be one of them, that it was finding new battery technology. So this, I mean, Discovery materials passed important tests using quantum mechanical simulations and stability checks. This means the AI didn't just guess, it found materials that scientists believe will actually work in real batteries. So it's a scale. This is amazing. And the smartphones, laptops, and tablets could run for days without charging. Power companies could store renewable energy much more efficiently. Cars could travel 500 to 800 miles on a single charge. And so this type of technology could change how, we work today.
Yeah. Yeah, exactly. But my question is like, how feasible is this versus the other battery technology that we've been covering?
Well, it's another race to the standard. So, like with all these industries, there'll be a standard or two, right? Like we all adopted AAA, AA batteries as an example.
Yeah.
And the devices use those types of things. We've all kind of come to grasp with lithium-ion and how to do it. We'll all come to grasp with one of these technologies. What will it be? Will it be the stretchable batteries that we got in the other one that we talked about before? Will it be something like this? I don't know, but I'm really looking forward to it. But it is a VHS versus beta kind of situation, or DVD versus Blu-ray, or HD DVD versus Blu-ray, where one technology wins out, and that might not quite be the case in power or batteries, just because we have EVs and we have portable electronics and we have large scale battery that we need for environmental, for storage. We talked about chemical battery, talked about environmental batteries that are size of a football field that change the gas status inside it, and that stores energy and then slowly release it. There's all these types of batteries out there and different types of requirements for them. Like storage for a city is different than storage for a home, or storage for a laptop, or storage for so we're going to see a few, but it'll only be a couple of those technologies, because the industry will standardize. We'll have factories that we'll know how to put out fires related to that. Like the industry standardizes just for efficiencies.
Yeah.
I don't know which ones are going to win, obviously,
Exactly.
but this kind of stuff is great as we start to move forward. We may see leapfrog. We are probably going to see a few years of different competing technologies as they hit the market. But, everything we see is 5 to 10 years out. This is still a ways away. But I really like where we're heading with all these. It's just, what is that saying? And someone's going to remind me. There's liars, there's filthy liars, and then there's battery engineers. And
Yeah.
So when you're dealing with this stuff, they always overpromise and underdeliver. And I feel that we're getting a lot of that when we talk about this new technology. But I'm hoping that we do see some stuff around the corner. I don't know if this will be the future. Like we talked about supercapacitors, which seem very attractive, but maybe not for everything. So we'll have to see which ones win. But I do love the fact that we're using multiple AI systems to find and then test these new technologies.
Yeah. Same here.
So let us know what you think. Is this the future? Or is there something else that's going to come? We talk about battery technology all the time. Let us know if there's a battery technology you think will win out. We'd love to hear your thoughts. So what do you got going on, John?
Yeah, I guess it's coming out maybe September. So we've got startup drinks. We've got Elevate. Well, that's beginning of October, but and Flowgrammer event.
Yeah, we have those monthly now. So check out, if you're doing business operations and AI and in the Toronto area, check out flowgrammer.ca for all our events. We do a low code, no code, also live coding events where we just get together, demo stuff, have great conversations. It's really a good time. Startup investor drinks will be back, and come out and see that, where startups get to pitch. It's open pitch, open bar. There's investors always in the room, and it's always a great discussion. We always have stuff going on. Check out torontostarts.com. Check out flowgrammer.ca. And John, if they want non-dilutive funding, where do they go?
Yeah, find me on LinkedIn, John Irwin. It's the best way. Reach out, send me a message, add me, whatever. Yeah, it's the best way if you have any questions about non-dilutive funding. This is coming out in September. FedDev should be open, but and maybe can export. So yeah, but if you need any help with anything else business related to your startup, where do they go for you, Craig?
Go to torontostarts.com, startupcoach.ca, but go to torontostarts.com for everything that we do. You can book a call with me there, either with Flowgrammer for business AI automation, or if you want to accelerate your business with some startup coaching. It's all there. I'd love to hear from you. Love to have your feedback.